In this video, we'll be talking about the rules for calculating atomic mass. Atomic mass is the average mass for any atom of a specific element. This takes into account the different isotopes of an element, which, just as a review, are atoms of the same element that have a different number of neutrons, giving them a different mass. With that, we also have to talk about percent abundance, which is what percentage of atoms of that specific element are going to be each isotope. To recognize one of these problems, the first thing we can do is notice that this actually contains the word isotope. We can also notice that we've got a couple percentages listed here, which are percent abundances. And we also have numbers with a unit of AMU, which are our atomic mass units. And so we've got some masses also. The last sign we can have that it's this type of problem is that it asks us what the element is. This is very common whenever you're dealing with atomic mass. The first thing we need to do in solving these problems is we need to move our decimal point 2 places to the left in each of our percentages. And we're just going to copy this at the bottom. And so our first one, which was 90.48%, now becomes 0.9048. We can do the same thing with our second percent and turn that into 0.0027. And our last percent, we can change to 0.0925. Then we can multiply each one of these by the mass that's listed with them. This 19.99 AMUs is listed right after the 90.48, and it says the 90.48% has a mass of 19.99, and so those two are going to go together. We're going to multiply them together in our problem. And then we can do the same thing with the 20.99 and the 21.99 AMUs also. Once we've got those multiplied, we can actually take all of those numbers and add them together to give us our atomic mass. When we do this, we get an atomic mass of 20.18 AMUs, which is very close to the atomic mass listed on the periodic table for neon, which is 20.18 AMUs. They're basically the same. Since those are almost identical, we can assume that our element is a sample of neon. Try this problem yourself. The answer is going to be in the description below.